In the figure shown, the maximum tensile force in the members of the truss is 1,500 pounds, and the maximum allowable compressive force is 800 pounds. Determine the maximum magnitude of P of the two loads that can be applied to the truss. Now to begin our analysis, let's begin by solving for the reaction at the support. So for the roller, it has a vertical reaction. Let's call this Py. And for the pin at A, it resists both horizontal and vertical component. So we have Ax and Ay. And then taking summation force horizontal, we can solve for Ax, considering rightward forces to be positive. So we have Ax going to the right plus the force P here going to the right equal to 0. Here we have Ax equal to negative P. Since the value is negative, therefore our assumption for the direction of Ax is incorrect. So Ax should be moving, it should be going to the left. And its value is equal to P. To solve for the vertical reaction, we can take summation force vertical, or let's begin with taking moment at point A to solve for By. So taking summation moment at point A equal to 0, considering counterclockwise to be positive, we have P at point D times the moment arm distance of 0.25A plus 0.75A. That is equal to A. Then minus the, this is negative because it will induce a clockwise moment. And then minus another force P times the moment arm distance of A. Then plus the reaction force By that will induce a counterclockwise moment times the moment arm distance of 2A equal to 0. So we have negative 2P times A plus By times 2A equal to 0. Dividing both sides by 2A, we get negative P plus By equal to 0. So we have Py equal to P. Now we can take summation forces vertical to solve for Ay. Taking upward forces to be positive. So we have Ay going up minus P at joint C going down plus P going up at joint P equal to 0. Here we have Ay and these two tensils, we have Ay equal to 0. So it exerted no reaction. Now that we have the reaction at these supports, we can now proceed analyzing each joint and solve for the forces in each member. Considering joint A, we have a horizontal force P and force member AD and AC. But first, we need to solve for the angle between the horizontal and AC and AD. To do so, we utilize the arctangent function. So, tangent theta here is equal to the opposite side, that is 0.25A, divided by the adjacent side equal to A. And the A term cancels, so we are left with 0.25, therefore theta is equal to arctangent of 0.25. That's equal to 14.04. And to solve for this angle right here, we consider this big right triangle and utilize the arctangent function. Since we have the opposite side of 0.75A plus 0.25A equal to A divided by the adjacent side equal to A, we get tangent theta equal to 1. So theta is just equal to arctangent of 1 equal to 45 degrees. Now we can analyze joint A. We have force P, force AD, and force AC, with an angle between the horizontal for force AC that is 14.04 and 45 degree for force AD. Now taking summation force vertical equal to 0, we get force AD sine of 45 degree plus force AC sine of 14.04 degrees, all equal to 0. Then we have summation force horizontal equal to 0. We have force AD cosine of 45 degrees plus force AC cosine of 14.04 degrees minus P equal to 0. Now we can use our calculator to solve for the value of force AD and AC in terms of P by going to mode 5.1. For our first equation, we have force AD with a coefficient of sine 45 and force AC that has a coefficient of sine 14.04 degrees equal to 0. For our second equation, we have force AD cosine of 45 degree and force AC cosine of 14.04 degrees. And moving P to the right, we will have positive P. And let's try to assume that P has a unit magnitude of 1. So we have force AD equal to negative 0.47 times P. Since we consider P to be a unit load, therefore we plug in back P so we can represent force AD in terms of P. And then we have force AC equal to 1.37 times P. And since AD is negative, therefore it must be in compression. Now we can start analyzing the other joints. So let's try to consider at joint P. So at joint P, we have force P going up, and assuming tensile forces, we have force PD and force PC, assuming tensile, and we have force P going up, and we have an angle here that's equal to 14.04 degree. By symmetry, this angle right here must also be equal to this angle, and force PD with an angle of 45 degrees. And taking summation force horizontal equal to 0, we have negative force PD going left cosine of 45 degrees minus force PC cosine of 14.04 degrees equal to 0. And take the summation force vertical equal to 0, we have force BD going up sine of 45 degrees plus force PC sine of 14.04 degree, and then plus P equal to 0. And we can basically move P to the right. That will become negative P. Then we can use our calculator to solve for force BD and BC in terms of P. So assuming a 1 unit load for P, we can represent force BD and BC in terms of P, just like what we do to joint A. So we have force BD negative cosine 45 degree and negative cosine 14.04 for force BC equal to 0. And in our second equation, we have force BD sine of 45 degrees plus force BC sine of 14.04 degrees equal to negative P. So let's assume a unit load of 1. So we have force BD in terms of P equal to negative 1.89 P. And then we have force BC equal to 1.37 P. So since BD is negative, therefore it is a compressive force. Now that we have BD, BC, AD, and AC, what is left for us to solve is force ED. So let's consider at joint, let's say joint C. So joint C has a downward force of P and a force of BC equal to 1.37 P, and it is tensile. And then we have another force EC, that is also a tensile force equal to 1.37 P. That is an angle of 14.04 degree. Because if this angle here is equal to 14.04, then by alternate interior angle theorem, this angle right here must also be equal to 14.04. And then we have an upward force, let's assume tensile, that is equal to force CD. And to solve for force CD, we take summation force vertical equal to 0. Taking upward force is positive. So we have force CD minus 1.37 P sine of 14.04 degrees minus another 1.37 P sine of 14.04 degree minus another force P, all equal to 0. So force CD is equal to 1.37 P sine of 14.04 degree plus 1.37 sine of 14.04 degrees plus P. So we have FCD that is equal to 1.37 times sine of 14.04 plus 1.37 sine of 14.04 plus another force P. So we have force CD equal to 1.66 P. Now that we have the value for the forces in each numbers, we can now solve for the value of P. It can be applied to the truss by assuming that each load here would carry the maximum allowable tensile and compressive force. Now for force BD, let's say it has a value of 800 pounds. It is compressive because it is negative. That's equal to 1.89 P. Solving for P, you get 800 divided by 1.89 is equal to 423 pounds. That is when we assume force BD. And if we assume force BC, that is carrying a tensile force of 1.37 P, you can let force BD equal to 1,500 pounds, equal to 1.37 P. You can solve for P, that is equal to 1,500 divided by 1.37. That is equal to 1,094. That is if we assume BC or AC, because they both have the same value. Next, we now proceed force AD. There is a value of compressive force of 0.47 P. Now let's plug in 800 pounds to force AD, that is compressive, equal to 0.47 P. So we can solve for P equal to 800 divided by 0.47. That is equal to 1,702. This is 1,702. That is if we assume force AD. And lastly, we have force CD. There is a tensile force of 1.66 P. So let's substitute 1,500 to force CD. So P here is equal to 1,500 divided by 1.66. That is equal to 903.61, or let's say 903 pounds. That is if you assume force CD. Now from these values here, the safest maximum magnitude of P here is 423 pounds. That is if we assume that force PD is carrying the maximum allowable compressive force of 800 pounds. Therefore, our answer here should be, that is the closest value, that is letter B, 425.